Lesson 3.1, Graphing Linear Equations. Our essential question is, how do you determine if an equation represents a linear or nonlinear graph? Our first new vocab word is linear. If you look at the first 4 letters in the word linear, what you see is the word line. So when an equation represents a graph that is linear, linear means that the graph is a line. The word nonlinear then, the prefix non means not, so nonlinear means that the graph is not a line. Back to linear, I want to draw a couple of pictures for you, just because I don't want you to be confused about the word linear. So linear is just a line. It could be an oblique line or diagonal line. It could be horizontal or vertical. But it is just one line. So it's not a line graph where you are connecting dots and you are connecting them with segments of a line. It's not like that. It's just one line. When we say the graph is not a line, it can be a lot of different shapes. And that's what we're going to be exploring today. What those different shapes could be for nonlinear graphs. So it could be curved like this. It could be V-shaped like this. So those are nonlinear. In order to figure out if our graphs are linear or nonlinear, we're going to make some T-chart tables. Remember that the x coordinate, or the input variable, is what we're going to work with first. So we can choose, because x is our independent variable, we can choose any values that we want for x and put them in the equation, and then solve the equation to get the output variable, which is y. So I am going to go with my favorite 5 numbers, 2, 1, 0, -1, and -2. If you choose really large values for your input variable, you'll end up with a really big graph. And I don't want to draw a really big graph, so I'm just going to stick with a couple positive, couple negative, and 0 for most of these. Now, if I put 2 in where the x is in my equation, y equals 3 times 2 minus 1. 3 times 2 is 6, minus 1 is 5. Then I move on to my next input variable, 1. 3 times 1 is 3, minus 1 is 2, and so on. 3 times 0 is 0, minus 1, -1. 3 times -1 is -3, minus 1 more, -4. 3 times -2 is -6, minus 1 more, -7. Now I just need to graph these ordered pairs. 2, 5, 1, 2, 0, -1, -1, -4, -2, -7. And then if I connect them, I should be able to tell if they are a line. These form a straight line. So I would say, is this linear? Yes. Yes, it's linear. And is it a function? Does it pass the vertical line test? If I drew vertical lines through this, all of these vertical lines would hit my graph once. So then yes, it is a function. So yes to both. Our second graph, I'm going to go with my favorite 5 numbers again. 2, 1, 0, -1, -2. This equation is a little bit more complicated to substitute into. 2 times x squared, so I substitute my 2 for x for my input. So 2 times 2 squared minus 5. Exponents have to come first. 2 squared is 4. So 2 times 4 minus 5. 2 times 4 is 8, minus 5 is 3. The next one, 2 times 1 squared minus 5. 1 squared is 1. 2 times 1 is 2. 2 minus 5, negative 3. If I substitute 0, 0 squared is 0. So 2 times 0 minus 5. 2 times 0 is 0. Minus 5 is negative 5. Now what happens if I change my 1 to a negative 1? Negative 1 squared is still positive 1. So it is still going to give me 2 times 1 minus 5. So negative 3. And then the same thing happens over here if I make a negative 2 instead of a positive 2. My input variable, negative 2 squared, is still positive 4. So 2 times 4 is 8, minus 5 is 3. So what you see if I graph these, 2, 3, 1, negative 3, 0, negative 5, negative 1, negative 3, negative 2, 3, is that this graph is not a line. It is nonlinear. It's called a parabola because this equation is quadratic, and we will work a lot more with these later on in algebra. So is this linear? No. Does it pass the vertical line test though? Yes. So it is not linear, but it is a function. Okay, the next one. Y equals 4 divided by x. Now on this one, because x is in the denominator, I want to use numbers that can be divided by 4. So on this one, I'm going to say my input should be 4. 4 divided by 4, 2, 4 divided by 2, and 1. Not 0, because you cannot divide by 0. That's undefined. And then I'll use negative 1, negative 2, and negative 4. So I adjusted a little bit based on what the equation looked like. So y equals 4 divided by x. So 4 divided by 4 is 1. 4 divided by 2 is 2. 4 divided by 1 is 4. 4 divided by negative 1 would be negative 4. Negative 2 would be negative 2. And negative 4 would be negative 1, like this. Okay, so 4, 1 is right here. 2, 2 is right here. 1, 4 is up here. Then negative 1, negative 4. Negative 2, negative 2. Negative 4, negative 1. This graph is not linear. I'm sure you could see that from the pattern of the dots. This is actually called a hyperbola. So, linear? No. Does it pass the vertical line test though? Yes. So it is a function, but it is not linear. Okay, our next one, absolute value bars. We can go back to my favorite 5 on this one. Y equals the absolute value of x, so the absolute value of 2 is 2, absolute value of 1 is 1, 0 is 0. The absolute value of negative 1 is 1, and negative 2 is 2. Because absolute value represents the distance away from 0 on a number line. 2, 2, 1, 1, 0, 0, negative 1, 1, negative 2, 2. This is a V-shaped graph, so it is not linear. It is not linear again. Absolute value graphs are V's, but it is a function. It passes the vertical line test. The next one, I will go with my usual 5. Y equals 2 to the power of 2. 2 to the power of 2 is 4. Y equals 2 to the power of 1. 2 to the first power is 2. Y equals 2 to the 0 power. We haven't worked with 0 and negative exponents yet. That will come later in the course. If you use a calculator, the calculator will tell you that 2 to the 0 power equals 1. It's kind of like an identity. The next one, 2 to the negative first power, if you put that one in the calculator, you'll see that it is negative 1/2 or negative 0.5. And the next one, if you put it in the calculator, negative 1/4 or negative 0.25. Oops, sorry about that. Not negative. All right. Positive 0.5 and 0.25. Okay, now ready to graph. The first one is 2, 4. Next one is 1, 2, 0, 1. Negative 1 is 1/2. Negative 2 is 1/4. So what's happening is this is getting closer and closer and closer. It's actually not ever going to hit that axis. It's kind of hard to draw with my smartboard with my marker being that thick. Move it up a little bit. There, that looks better. So it's going to get closer and closer and closer to that x-axis, but never actually touch it. So this is not linear again. So linear, no. But, like the others, it does pass the vertical line test, so it is a function. Another exponent on this one, y equals x to the third power. I'm going to put in my favorite 5 numbers again. So y equals 2 to the third power. 2 times 2 times 2 is 8. Y equals 1 to the third power. 1 times 1 times 1 is 1. 0 to the third power is 0. Negative 1 to the third power. This means negative 1 times negative 1 times another negative 1. So that will give us negative 1. Similarly, negative 2 to the third power is negative 8 because you're multiplying 3 negative numbers times each other. So if I graph this, 2, 8, 1, 1, 0, 0, negative 1, negative 1, negative 2, negative 8, you will see a cubic curve like this. And this is not linear, so linear, no. And is it a function? Yes, it passes the vertical line test. It looks like it's going to go straight up and down because it's getting really steep in each direction, but it will not. It will not. And you could test it by substituting more numbers and you would see that you do not get the same value. Okay, square root. I'm not going to use my regular values for this one because I want you to think about what numbers are good numbers that you can take the square root of. We cannot take the square root of a negative number, so I'm not going to use any negative numbers. The square root of 1 is 1. The square root of 4, square root of 4 equals 2. So if y equals the square root of x and I plug in a 4, I will get 2. The square root of 9 is 3. And I could keep going. The square root of 16 is 4. 1, 1, 4, 2, and then 9, 3. I could put in 0. The square root of 0 is 0. And you can see that this one does curve. It almost looks like half of that parabola that we had when we had x squared. So is this one linear? No, it's not linear. Does it pass the vertical line test? Yes. So we're seeing a lot of functions that are nonlinear. A lot of functions that are nonlinear. The first one that we did was linear. The rest of them since then have been nonlinear. So you should be starting to think about the kinds of things that we saw in the equations, without even graphing. What did you see in the equations that made these graphs nonlinear? Something to think about. Now this one, we are taking our input variable and multiplying it by 1/2. and then adding 3 to it. So the kind of numbers that are good to multiply by 1/2 would be even numbers. So I'm going to use 4, 2, 0, -2 and -4. Half times 4. Half of 4 is 2, plus 3 is 5. If I plug in 2, half of 2 is 1, plus 3 is 4. Half times 0. Half times 0 is 0, plus 3 is 3. Then -1, nope, -2, sorry. So half of -2 is -1, plus 3 is 2. And half of -4 is -2, plus 3 is 1. So we've got 4, 5, 2, 4, 0, 3, -2, 2, and -4, 1. This is linear. So yes, it's linear. And is it a function? Yes. So we had two linear functions, and a lot of nonlinear functions. So this is a click and drag. We've got some graphs. Those are usually the first ones that get clicked and dragged in class. So these are nonlinear, these two are linear, they're lines. Then looking at these equations, I know that an exponent gave me a graph similar to this. An exponent of 2 was a quadratic. I know that when x was on the bottom of a fraction, it gave me something that had just one, that had 2 curves in it, so I'm going to put it by that curve. Square root gave me something with a curve. Absolute value gave me a v. And an exponent that's a variable. This is 2 to the x power. That also gave me something that was curved. Okay? And then this one is linear. That's in slope-intercept form, and so is this. So when the x is just a plain x, and it's not on the bottom of a fraction,
Please turn your
it's
TV
linear.
to channel 67.
You should be able to write a summary now and work on your homework.